Assalamu alaikum wa rahmatullah. Dear all, I'm Abdullah Hussein from Al Bayt University, Jordan. My colleagues are Inas Aburud from Al Bayt University, Fatima Al Khadri and Mashhur Wardati from University of Sharjah, United Arab Emirates. In this way, we will talk about atmospheric parameters of individual components of the visual triple stellar system, Hipparcos 32475. In this way, we will give an introduction about binary and multiple stellar systems, source of stellar parameters, and then we will analyzing the visual triple systems Hipparcos 32475. First, we will show the dynamical solutions and then the atmospheric parameters. Then we will give a conclusion. First of all, binary and multiple stellar systems are referred to a system of two or many stars orbiting around their common center of mass. Binary and multiple stellar systems are very important to study because more than 50% of the galactic stars are binary and multiple stellar systems. And astronomers use binary stars or multiple stars for calculating the masses of the systems using Kepler's third law or another way. This shows the structures of orbit of binary stars and how they are rotating about center of mass. Will Venegas said that there are no single stars, there are understudied stars. The source of stellar parameters, we have direct measurements, observations such as magnitudes, parallax, positional measurements, polarimetry, not tips, nothing, and calculated distance magnetic difference. Depending on laws and equations, we have some stellar parameters, but how we can get the fundamental parameters of individual components of binary and multiple stellar systems. We can have a computational method such as dynamical solutions and Al-Wardat method for analyzing binary and multiple stellar systems. First of all, we will talk about the system Hipparcos 32475. As shown here, this is a system located at 6 hours. This is some identifier and different catalogs such as Washington double star catalog, Hipparcos double stars, and Hipparcos catalog. This is a visual triple stellar systems. AP pair was discovered in Hipparcos mission in 1991 with a separation of 400 milliarc second. In 2015, the third component resolved to the system by discovering a small angular distance from component P, almost equatorial triangular configuration consisting of main component A and subsystem PC. Now we talk about the orbital elements estimated using the orbital or from the orbital solutions. We have mainly 7 orbital elements: period, time passed through periastron, and the eccentricity, the major axis, the orbital inclinations, the negative of the periastron, the position angle of ascending moon. The orbits of Hipparcos 32475 have 3 orbital solutions in 2 years. First one in 2019 from Zorica Chukovic in 2019. In 2020, Chukovic published a new orbit and Tukovenin published orbit in 2020 in red line. We have a very large difference. This is the orbital parameters. We have a difference in orbital period around 48 years from Chukovic and 8 years from Tukovenin, and the third one is 128 years. We can use semi-major axis and orbital period along with distance or parallaxes to calculate the masses or mass sum of the systems using Kepler's third law. But in this way, we have a very large difference using the same parallax from different solutions and a very large difference using different parallax. Because of that, we will use Al-Wardat method for analyzing binary and multiple stellar systems. What is the uniqueness of this method? It helps to estimating atmospheric and fundamental parameters of the individual components. It investigating duplicity and multiplicity of the multiple stellar systems. It helps to estimating a precise spectral energy distributions, a precise dynamical parallax along with orbital elements availability. It helps to estimating precise age of the systems and discuss formations and evolutions of binary and multiple stars. Observational data, here we have visual magnitude, color index, and BT4 or blue filters and visual filter from TIFO, parallax of Hipparchus, parallax of Gaia data release 2, and parallax of Gaia data release 3. This is the relation used to build spectral energy distributions for entire system of multiple stars. Here we have flux of the system, and this is the distance, and here h of lambda and radius. H of lambda is a flux of individual components. We can have this flux from any model atmospheres, and this where we use Atlas 9 Kurook's model. The following parameters used for individual components to build spectral energy distribution. We have a very large difference between temperature and radii. Here we have the synthetic spectral energy distributions for individual components. Here the red one is for entire flux, the green one is for component A, the blue for component B, and purple for component C. Alberta synthetic photometry to show or they calculate magnitude and color indices for other photometric quantities from spectral energy distributions function by comparing the spectral energy distribution along with flux of Gaia or Vega. Alberta synthetic photometry result we have using Johnson filters and Strongren and TIFO passband to calculate it for entire and components filters. Here we fit the visual magnitude and color indices for entire and individual components. Here, the estimated atmospheric parameters for effective temperature and radii used to calculate luminosities, colorimetric magnitude, and absolute visual magnitude. The listed or the estimated parameters are listed here. But how we can calculate masses and age? By locating the positions of component in evolution tracks and isochrones, we can estimate the masses and the age. As shown here, the three components are in the same age line with 1.26 gig-year. This gives an index about the formation method which adopted for the formation of the system. It is a fragmentation. Now, we will compare estimated masses from Alberta method with dynamical solutions here. We have the first one from Chukovich, and Chukovich 2020. And here the estimated mass sum for individual component 1.5, 0.82, and 0.8. The mass sum is the 3.12 AMSAM. It is close to mass sum of dynamic of Tukovenin and Zurika 2020. This is the best solution of the three solutions are of Zurika, but it need more positional measurements to have accurate orbits. Conclusion: the fundamental parameters are estimated for Hipparchus 32475 using Alwardat method for analyzing binary and multiple stellar systems. The result assured the accuracy of the orbit of Zurika 2020. The component positions on the HR diagram, evolution tracks, and isochrones were located using the estimated parameters, where evolution tracks and isochrones we have used Gerardi tracks. The result shows that the component A start to evolve from the main sequence to the subgiant stage, while the component B and C are still in main sequence stage. We estimate the age of the system as 1.26 years from the isochrones of hierarchy. Finally, the fragmentation is proposed as the most likely process for the formation and evolution of the systems, because that the three components are in the same isochrones with the same age. Thank you. And any questions?